Hi, this is Ramneet Kaur once again, and I am coming back with the AP Calculus BC Chapter 9A voiceover. So this is continued on after 9.1 and 9.2. So now in 9.3, which is the integral test and P-series, we're going to begin by going over the integral test, which is basically the sum of all heights of a function. And this says that if the integral of 1 to infinity of f(x) of d of x converges, then the sum it starts at n equals 1 going to infinity of a of n also converges. Three conditions that need to be met in order to follow through with this are the first one being a of n has to always decrease. The second one being a of n has to be continuous. And the third one is a of n has to be always positive. This is an example of checking whether the problem is converging or diverging through the integral test. So given the sum as n equals 1 going to infinity of 1 over n squared, so you have to do the three checks first. The first check being decreasing to check if it's decreasing. So f of x equals 1 over x squared, substituting the n's for x's. To check for decreasing, it's common to do the derivative. So f prime of x equals negative 2 over x squared. And it is decreasing because of the negative sign up front, meaning yes, it does fill that condition. The second condition being if it is continuous. It's only discontinuous at x equals 0 because of the denominator. But other than that, yes, it is continuous. And it is always going to be positive because of the squared as the denominator. Since all of the three conditions are checked off, you could continue on to the integral. So for the integral, I set it up as integral from 1 to infinity of 1 over n squared. So since it's an infinity on top, I substituted and created a limit as b approaches infinity and had the integral be 1 to b of 1 over n squared. I continued this and had it be limit as b approaches infinity of negative 1 over n, and I had to later plug in 1 and b. So when I plugged in 1 and b, it was limit b approaches infinity of negative 1 over b minus limit as b approaches infinity of negative 1 over 1. So limit b approaching infinity would be 0 because negative 1 over infinity would approach 0. And then you would subtract that by limit as b approaches infinity of negative 1. And that would be negative 1, but negative times the negative up front from the subtracting of the equation would create a positive 1. And so this would give you the ending conclusion of the sum of n equals 1 going to infinity of 1 over n squared converges. Next, moving on to checking the divergence and convergence through the P-series test, otherwise known as the power series. So first, knowing whether it's a P-series or not, you would have to check. So the basic way it's written is the sum as n equals 1 approaching infinity of 1 over n to the p. So this would mean that your n has to be to an exponent, and that exponent, your p, is the number that you use to see whether it converges or it diverges. So if it converges, that means that the p is greater than 1, and if it diverges, that means the p is less than or equal to 1. For example, in the first example shown, it's the sum as n equals 1 to infinity of 1 over n. This diverges because the p would be 1, because that's the exponent of n, and since that equals 1, that means it diverges. In the second example, the sum as n equals 1 approaching infinity of 1 over n squared converges because the p would be 2, and since 2 is greater than 1, that means it converges. So to approximate the sum of convergence series, sum n equals 1 approaching infinity of 1 over n to the fourth by using the 6 terms, and also estimate remainder and max error of your approximation. To begin this out, what you would do is you would list out your 6 terms by plugging in numbers 1 through 6 into the equation of 1 over n to the fourth. So it's done below. So s of 6 equals 1 plus 1 over 16 plus 1 over 81 plus 1 over 256 plus 1 over 625 plus 1 over 1296, and so on and so forth. And adding them all together would give you 1.0811. And so afterwards, you would have to use the equation R of n, which is for remainder, equals the sum minus S of n, which is the sum at a specific number, which is to 6th term as we used before. And this would usually be bounded by 0, which is less than or equal to R of n, and that's less than or equal to the integral of n to infinity of f of x of d of x. But we would write this down right here below as integral 6, which is how many terms you have, to infinity, and then of 1 over x to the fourth dx. But since you don't want to leave it as an improper integral, you would bring it out as a limit. So limit of b approaching infinity of integral 6 to b of 1 over x to the fourth dx. You'd make that limit as b approaches infinity of negative 1 over 3x cubed, 6 to b, and limit as b approaching infinity. Then you would plug in the 6 and the b going first because that's a higher number. So that would make inside the parentheses be negative 1 over 3 times b to the third minus a negative 1 over 3 times 6 to the third. And after calculating that out, you would get 1 over 648, or in decimal form, 0.0015. So continuing that previous problem, given to you what we figured out after plugging in the first 6 terms into the equation, s of 6 equals 1.0811, and also we figured out the remainder to be 0.0015. So s of 6 is less than or equal to the sum as n equals 1 approaching infinity of 1 over n to the fourth, and that would be less than or equal to the integral of 1 to infinity of 1 over x to the fourth. And the max error you would calculate by adding those two numbers together, so 1.0811 plus 0.015. So you would add the amount of terms that you were specified to figure out the number till, and the remainder, and that would give you 1.082 as your max error, which is your answer in the end. Since this is what we went by to figure out the last problem's max error, which was the sum until the number of terms that was specified to figure out added to the remainder, and that gave you the max error. You could also do this in different ways and change the formula when needed. For example, to find out the remainder, you could do the formula of max error minus the sum until the number of terms that you were specified to get. Or you could figure out the number of terms, the sum of them, by doing max error minus the remainder. And you could just mess with the formula to figure out what the question being asked is trying to make you find the answer to. Thank you for watching my voiceover and notes for AP Calculus BC Chapter 9A. The videos that were done were 9.1, 9.2, and 9.3. Thank you for watching.